Okay, welcome to pre-calculus. I'm going to start on 4.1. Uh, this is going to be essentially my handwritten notes. I'm going to walk you through them, walk you through some problems, and then just kind of go from there. So we start out very simply with the idea of an angle. An angle essentially is two rays. A ray has an endpoint and all the points to one side of it. So it has two sides here. A terminal initial side, usually where it starts, and then it opens up to a terminal side. So TS for terminal, IS for initial. Where the two rays meet, we call it a vertex, kind of like the corner of the angle, if you will. All this at the beginning is just definition, so just bear with me here. An angle in center position is one that lives on the x and y axis. Okay? Now, you have positive x, negative y, and positive y. This is the positive x-axis, so an angle in center position is an angle that begins at the positive x-axis. This one in particular goes against the clock, or what's called counterclockwise. Initial side, terminal side. So we're going to assume that our angles that we're dealing with are going to initiate at the positive x-axis. When you talk about the x-axis and the x and y-axis, excuse me, what's called the Cartesian coordinate system, you have quadrants. You have the x and y axis breaking up this system into four quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Upper right, when x and y are both positive, greater than 0. Quadrant 2, when x is negative and y is positive. That's what this says. And then quadrant 3, when x and y are both negative. And then quadrant 4, when x is positive, y is negative. That's what this is saying. Greater than 0, less than 0. Now, when you talk about an angle in center position, you talk about its movements. If you're on the positive x and you go essentially against the clock, your angle is positive, as this is saying, counterclockwise. Assuming that we're always going to start on the positive x, when you go with the clock, essentially that's going to be your negatives. So you have negatives that are clockwise, positive that are counterclockwise. Okay, as far as all of this goes, move this a little bit here. As far as this goes, a lot of you are familiar with this, but if you're going with the clock, against the clock, you're going to the positive measure. This is the 0 degree mark. As you move completely vertical, that's your 90 degrees. As you move completely horizontal, that's 180. Back down is 270, and all the way across is 360. So every one of these quadrants essentially is 90 degrees that you're adding. So 90, 180, 270, 360. Now, if you continue the revolution, you can spin multiple times. Another 90 is 450, 540, 630, 720. So this essentially is just kind of two revolutions, but you can go as many times around the clock as you want. It's not a problem. If you go in the negative, same thing happens, except you're going in this direction. You're going with the clock, so you're going down here as 90, as 180, as 270, and at 360. But because we're going with the clock, they're negatives. Negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, negative 630, negative 720, negative 810, negative 900, and so on. You spin every time at negative by 90 increments of 90 degrees, essentially. You have the idea of what are called coterminal angles. So there are two angles or more with the same initial and terminal side. So you can see that a little bit better. If you're given 100 degrees, again, 100 degrees lives in the second quadrant. It's 10 degrees past 90, 80 degrees short of 180. So I can take this angle as my given angle, and I can say, well, look, if I start, again, assuming that we're starting the positive x, I can go in the negative direction and meet up with them here. So this angle, which marks negative 260, has the same initial and same terminal side as the 100 degrees. So it's a coterminal. So essentially, we're subtracting by 360 because this forms a circle, but you have to take away because you're going the negative side. Now, suppose instead of going just one time in positive, let's suppose I spun completely around the circle to 360 and then back here where I started. So if I spin 460 degrees, I start and stop at the same place as the given angle, 100. So in this case, I add 360. So 460 is coterminal to the 100. So 460 is coterminal to 100, and 100 is coterminal to negative 260. So 460, 100, and negative 260, they're all coterminal with each other, essentially. So essentially, I want to point that out here. Okay, so what if I go in the negative direction, but I spin, again, a complete revolution? Well, that means I would go negative 260 and then a negative 360 more. So I'll keep subtracting. So a second time around, I would subtract 360 again. What if I decide to go one more time around the circle here, but I go another 360 around? So 820. So ultimately, I can spin 360 each time around the positive, or I can spin 360 each time around the negative. So I subtract my negative 360, the number of times I spin around, and I add 360, the number of times I spin around. So that's how you get the coterminal angles. You keep adding and subtracting by 360. And this goes on forever and ever. So essentially, any angle has an infinite number of coterminal angles. And so that's how this works. Okay, so let's see. Let me turn the page here. Again, if I may here. Again, if negative 90 is my given angle, if I add 360, I get 270. If I take away 360, I'm at negative 450. So I keep adding and subtracting 360. That's essentially what I'm saying. Each angle has an infinite amount of coterminal angles. The idea is adding or subtracting 360. N is the number of times you spin around. Theta is, if theta is any given angle, then all coterminal angles of theta are of the form theta plus or minus 360 n. Now, we're in the world of degrees, so this is 360. In a while, when we learn about radians, this will be the value 2 pi. Okay, but for right now, that's what we're looking at, 360 in terms of degrees. Let's see here. Now, reference angle. A reference angle is a given to a given angle is an acute angle formed with the terminal side, or the end of a given angle, and the nearest x-axis. Okay, so if 250 is one of my angles, is the angle that I start with. Initially here at 250, that's my given angle. Then I'm trying to form with the right or the left side of the x-axis. So either I can form this angle, or I can form that angle. Now both of them would be the x-axis, so either half of the x-axis, but this is the nearest half. So this is actually, if you want to talk about direction, that should actually be negative 70. But reference angle is an acute angle. An acute angle is an angle that lives between 0 and 90, so it has to be positive, cannot be negative, or it could be 0 at worst. So here, because it's 250, I pass 180 by 70, so the reference angle is 70. This one, negative 30, you see, I can either go this way, that's going to be an obtuse angle, or I can come in this way. Now you can say that this is negative 30 degrees, which it is, but the reference angle is always positive. So you can think of the reference angle as being the absolute value if you're talking about direction in the world of positive or negative measure. The reference angle will be the absolute value. If it's negative or positive, it's just positive. So the reference angle can never be negative. Always positive. Always has to be less than 90. Or essentially, again, reference angle, because acute is can I guess be 0. Reference cannot be 0 degrees. Reference has to be greater than 0. It has to be positive and less than 90. So here, negative 210. Even though I pass this guy by negative 30 degrees, the reference will be the absolute value, or just 30 degrees. Here, if it's in the first quadrant, its reference is essentially 60 degrees here, 60 degrees away from. Now, number 5 and number 6 and number 7, if the angle is 180, then the only axis that it makes here, or the reference angle that the acute angle, or the nearest x-axis is negative where it lands. So 0 degrees essentially would be the reference angle. But this makes no sense. So I guess if I have to here is a, let me go up here. Right here, positive. Essentially. It cannot be 0, and it cannot be negative. So, and it can be greater than 90. So here, this has no reference angle. This one down here, the nearest x-axis is either positive or negative. That's 90 degrees. That wouldn't be a right angle, not be acute. So this one has no reference angle. So 5 and 6 have no reference angle. So an angle in center position whose terminal side is on the x and y axis does not have a reference angle. So if any angle lives or any angle ends on the x or y axis, we consider it to have no reference angle. As long as it ends in one of the other quadrants, you're good. So this one ends in quadrant 3, quadrant 4, quadrant 2, quadrant 1. This one, number 7, ends in quadrant 2. It's 100 degrees. Its reference is 80, the nearest x-axis here, 80 degrees. And so that's how this works. Okay, let me put it a little closer so you can see, if I may here. No reference on number 6. Continuing on. Now we talk about radian measure. It talks about length, sort of how arc length corresponds to opening of an angle. So the circumference of a circle is 2 pi r. That should be from your past. That's how you find the distance around the circle. The arc length of a circle, the length of the whole circle around. Essentially, that's the circumference. If the radius is 1, the circumference is 2 pi, which is the distance around the circle. But 360 is also 1 revolution around the circle. So if you're at 1, you spin around, the whole circumference is 2 pi. But the angle measure is also 360. So there's a connection there. So the idea is that 360 is the same thing as 2 pi, or 2 pi is equal to 360, essentially. You can't really say an arc length and a degree are the same, but you kind of think of it as equivalent. And so we call it equal. So if 360 is 2 pi, then half, or 180, is half of 2 pi, or just 1 pi. So 180 is just pi. If you take half of 180, that's half of pi. If you take a third of 180, that's a third of pi. If you take 1/4 of 180, which is 45, that's 1/4 of pi. If you take 1 out of 6 of 180, that's pi over 6. So all these equivalents hold, because this one and this one hold. Well, this one, it doesn't really matter. We tend to go with this one more often than not. So because 180 is pi, you get some other angles that you get factors of 180. Numbers that divide into 180 evenly. 90, 60, 30, 45. So you get special angles here, and the reason that these are special because we're going to use them a lot in the upcoming lessons. They essentially are going to be angles instead of a triangle. So now, using this idea, we can go from one to the other. We can say, well, if we're in the world of angles, if we're in the world of degrees, we can go to the world of radians, so to speak. And if we're in the world of radians, we can come back to degrees. So if you're in the world of radians, everywhere you see pi, you bring in 180. So 2 pi over 3. Now pi, again, is 180. Or pi over 3 is 60. So because it's 2 pi over 3, pi is 180 divided by 3. If you look at it separately here, just the pi over 3 part, that's 180 over 3, which is 60. And then 2 of those 60s is 120. So in the world of radians, 2 pi over 3 corresponds to 120 degrees. 5 pi over 6 is the same thing as 5 times pi over 6. Pi is, again, 180 divided by 6 is your 30. So this is 5 of those 30, so it's 150. Pi over 2, again, is 180 over 2, or 90. Pi over 4 is 180 over 4, or 45. Pi itself is 180. 5 pi then will be 5 times 180. And so on, essentially. So 3 pi over 2 would be pi over 2 is 90. 3 times that is 270. 5 pi over 4 is 180 over 4, or 45. So 5 pi over 4 is 225. Negative 2 pi will be negative 2 times 180, or negative 360. This works for negatives and positives. Doesn't matter what direction. Again, negative because you go in the clockwise direction. Negative 7 pi over 4. Pi over 4 is 45. Times negative 7 is negative 315. So there's also another way you could look at this, if you wanted to. There's an idea where you can actually multiply by pi over 180. Oh, sorry, 180 over pi. Any one of these things you can multiply by 180 over pi. So let me do this off to the side here. 2 pi over 3 times 180 over pi, because it's a relationship. You're doing conversion analysis. So the idea is to get the pi's to cancel. And so 180 over 3, 3 goes into 180 60 times. So this is really 2 times 60, which is 120, which is what I was trying to tell you over here. But sometimes they just say, well, what about 7? What if it didn't have a pi in the problem? Well, in that case, then you would actually have to do 180 over pi. This essentially would be 1360 over pi. Now, pi is understood to be the relationship 3.14 dot, 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 dot. So if I take 1360 and I divide it by pi, you see 7 would be about 432.9 degrees. I don't really want to get too much into this because in our work, we're going to do a lot of these. So this decimal doesn't really help you much. I just threw that in there so you can have that in case you run across a problem later on. Okay. So let me scratch this out. It's not really important here. I don't want to mess the notes up when I send them to you. So that being said, if when you go from radians to degrees, you take the pi as 180 and go backwards. Same thing with degrees. Now you take the degrees, you got to say, well, how does this relate to 180? Where you say 60 is really a third, 1/3 of 180. Or how many times does 60 divide into 180? Well, 3 times. So pi over 3. 90 goes into 180 twice. So 180 over 2 or pi over 2. 180 is just pi. 450 now. Now 450 you can't say, well, how many times 180? So you look at numbers that divide into 450. So you say, well, 450 is a multiple of 90. 90 is pi over 2. 450 is 5 of those 90s. So 5 pi over 2. 120, you can say, well, not 120. 120 won't go into 180 evenly, so you go into these things and say, well, do any of these divide into 120? Well, 60 and 30 do, but 60 is bigger, so we go with 60. We say 60 divides into a 120 twice. So 60 times 2 is 120, but 60 is pi over 3. 300 is 5 times 60. 60 divides into 300 5 times. So 5 pi over 3. As you do this, pi over 3 will be 60, pi over 4 is 45, pi over 6 is 30. These will just kind of roll off your tongue. Pi over 2 is 90, pi is 180, as you do this over and over and over. 210 is 7 times 30. 30, again, is pi over 6. So 7 pi is over 6. Negative 330 would be 11 times 30. Negative 11 times 30. 30 is pi over 6, so negative 11 pi over 6. And then negative 30 would be negative pi over 6. Negative 225 would be negative 5 times 45. So negative 5 pi over 4. But now if you want to go the other way, you would say, well, just multiply by pi over 180. So if I may here, let's take 210 for instance. This one, number 7. Instead of multiplying by 180 over pi, you're going backwards, so you do the opposite. You do the reciprocal. So times pi over 180. So the idea is that this is 18, this is 21. They both have a 3 in common. But now being 210 and 180, they share a 30 in common. So 7, 6. So 7 pi over 6. Okay? Or what if you have, I don't know, 3 over pi degrees? We multiply pi over 180. That would be 1 out of 60. So that'll be 1 out of 60 radians here. RAD for short. 1 out of 60.0 something something. It's real small here. 0.02 degree, 0.02 radians, but it's not really important here. Just what's important is that you understand how these work. So when you see the notes, you're gonna have a lot of scribble here. but hopefully it'll make sense when you see it again. Okay, so just throwing that in there. I'll put a little asterisk here, I guess, if you will, just to kind of point that out. Moving on. Well, actually, the next part is 4.2 to 4.4, so it's a lot. So we'll stop here for a moment.